In this section, let us look at the concept of redundancy or backup power oxygen. First, we have to understand the delivery points and establish our consumption in this section. So let me recap the consumption patterns over here, which I have done in my previous sections. If you look at a normal oxygen prong, then the delivery pressure should be around 3 LPMs. This is averaged out. If you are using a nasal cannula, a mask, it might be around 4 LPM. Of course, there might be some patients which require higher delivery. Now these are the averages I am setting up so that you can come to some conclusion. If you are using NRBM masks, which are used for typically when the oxygen higher concentration is required, the delivery point may be around 6 LPM, 6 liter per minute. Overall, your O2 bed averages should be around 5 LPM. If you categorize all of them, sum up together 5 to 6 LPM is somewhere you should target. If this is not happening, something is wrong. If it is a critical facility, it will be on the higher sides of 6, and if it is a facility like a DCHC, it will be on the lower side. So this is how you have to look at the parameters. Then when you look at the consumption of HFNO, it might go average of around 50 LPM. The consumption of NIV another 50 LPM. Consumption of an intubated patient will be around 25 LPM. The BiPAP average will be around 10 LPM. Put this into a chart. Put up all your type of patient beds and come to your LPM, the consumption of liter per minute of the gaseous oxygen. Once you have this figure, you will understand how many LPM of gas is being required. Now let us look at the capacities. The jumbo B-type cylinder will be around 7,000 liters of gaseous oxygen. If you look at the class D type of a cylinder, it will have 1320 kind of oxygen. This is mostly used while shifting the patients. If you look at your Dura, it will have 200 liters of liquid cryogenic oxygen or 240 liters of liquid cryogenic oxygen. And from 1 KL right up to 20 KL or 25 KL, you may have your LMO plant, and there can be multiple such LMOs and the vaporizer. Put up all your capacity. Check what is your oxygen generator plant generating and how much oxygen beds it is supporting, and establish what is your consumption. I have put up a very simple calculator in this section which will help you to estimate by and large how much is your oxygen going to last. I have put some margin so that there is a residual oxygen which is required to maintain the pressures in LMO, so that delivery is available at the required pressure. There will be always certain oxygen into the cylinder left. It will never be 100% consumption, as certain bar of pressure will be required to ensure the delivery of the oxygen. Having said this, after establishing all of these LPMs and portion of the oxygen management, we have a benchmark of how much capacity our main plant is there, what is the consumption. And then you need to plan a backup. A backup should be good 4 to 8 hours of backup in case your primary source fails. And another design important parameter, do not have a single point of failure. If you have LMO, if you have 2 outlets, use 2 vaporizers, use 2 PRVs. PRVs can become a big bottleneck. If required, use more than 2 PRVs. Separate out your systems. See that there are 2 oxygen pipelines running if your plant is far away from the hospital. Probably build up a buffer vessel near your hospital. A small 1 KL like of vessel will not require a PESO permission, while a large setup is going to require a PESO permission. See that this is done. There is a redundancy. So if you have a LMO, that means your hospital is having very high consumption. It might require a backup of Dura cylinders to sustain that kind of ventilator loads, that kind of oxygen requirement, even for 4 or 8 hours. If you are having Dura as your primary system, your Jumbo might become your backup system. If you are having a oxygen OGP plant, a PSA technology plant delivering oxygen, then a Jumbo or a Dura bank might be its backup. In this case, you rotate the Duras, rotate the cylinders after certain time so that you don't waste oxygen. Plan a proper backup system so that the patients never suffer. Plan some bedside oxygen cylinders for emergencies. Rotate them. It's very, very important. Doing all this will give you a good redundant oxygen system.